Welcome back. The last sorting technique I'm going to show you is this one called a quicksort. Like the merge sort, it is also a recursive sorting technique, but it works in a different way. Here's how. So it is recursive. What you do is you designate one element of the array to be a pivot element. Typically, you pick the first element of the array to do that. Now, I've seen some algorithms where they pick the last element, but more commonly you pick the first element. So that's always a good thing to go with. Using that pivot element, the next thing you do is you divide the array into two parts like this. You put all the elements less than the pivot before it, and then all elements greater than the pivot after it. This will involve going through the array and doing swapping. Now, this slide says this is done by searching from both ends of the array. You can do that, but it's not necessary. You can search from just one side if you want. Typically, people search from the beginning of the array and don't search from the end. But if you can do it from both sides, that's perfectly fine. That at least puts the pivot element in its proper position. Now, that doesn't mean everything on the left and right of the pivot is in the correct order yet, but this is where the recursive part comes in. Now you do another quick sort on the elements that are less than the pivot, and you do another quick sort on the elements greater than the pivot, on the left and the right. Here's a picture of what we're talking about. So here is your initial array list. And as you can see, the 8 is the first element, so in red we've made that the pivot. Now, depending on how you search through the array, the numbers may not be totally in this order, but what happens is eventually everything to the left of the pivot element is less than that element, and everything to the right of it is greater than. Now, as you can see, what's to the left and the right is not perfectly sorted yet, but at least we know that all elements to the left are less than our pivot element, and all elements to the right are greater than our pivot element. So what happens now is we will do another quick sort, but just on this part of the array. So now the 6 becomes the pivot element. And so now, as you can see down here, everything to the left of the 6 is less than 6, and everything to the right is greater than 6. Similarly, we'll do a recursive quick sort on these elements that are greater than the original pivot. So the 12 becomes the new pivot. And after the first time through, you can see everything to the left of the 12 is less than 12. Everything to the right is greater than 12. Well, then you do it again. In this case, the pivot becomes the 4. That gets sorted. And eventually, all that is sorted. The 8 is still there. Similarly, on the other side, in this case, the 10 becomes the pivot. And this gets sorted. The 12 is still there, and you have 14 and 15. So eventually, this array is sorted in that way. That's how a quick sort works. Now, how do you code it? Well, I'm not going to give you the code, but I will give you an idea. Typically, a good idea, since this pivot element thing is so crucial, we give it its own function. So here I have a function called pivot, and I give it 3 parameters: the list, a pivot index, and an ending index where the array ends. So as it says here in the comments, this function gets all elements less than the pivot element to the left of the pivot element, and all elements greater than it to the right of the pivot element. It says the pivot element should be 0 the first time this function is called. At the same time, as you can see, basically I'm calling the quicksort function here, but this will in turn call the pivot function. So my initial index is 0, and my initial end index is the index of the last element, the length minus 1. So the way this pivot function works is as follows. It says use a loop starting at the index of the element after the pivot. So you don't start comparing at the pivot, you do it at the element that comes immediately after the pivot. It says this loop will use swapping to get all elements less than the pivot on the left and all elements greater than the pivot element on the right. This might involve another variable inside your function. It then says when it's done, the function should return the new index of the pivot element after all the swapping is done. So when this pivot function is finished, yes, the pivot element's going to move. And this function needs to return the index of the new location of that pivot element. Now, as I said, this pivot function is contained inside a quicksort function. As you can see, we have three parameters. We have the list you want to sort, the leftmost element of the index of the leftmost element, and the index of the rightmost element. According to the comments, it says this: when this function is initially called from main, left should be 0, and right should be the index of the last element of the list, which, as you'll notice, is exactly what I'm doing here. Left is 0, right is length minus 1. When you initially call this function, that's what you should do. The first thing it says it will do is it will call the pivot function to get all values less than the pivot value on the left and all values greater than the pivot value on the right. So the pivot winds up sort of in the middle, relatively speaking. Now it's going to recursively call the quicksort function. Okay, your initial call of the pivot function, you start with the array completely unsorted. So the initial call of the pivot function will get your first pivot element, which is the first element, into the middle of the array, sort of. But more importantly, it gets all elements less than that pivot to the left of it, and all elements greater than that pivot to the right of it. Then you call the quicksort function again, but now you just send it the elements to the left of the pivot, and then you call quicksort recursively a second time and send it all the elements to the right of the pivot. Now, of course, in a recursive algorithm, you need a base case. That's this last comment here, which reads as follows: all this should be done if the left parameter is less than the right parameter. These indexes are going to keep moving. The minute the left parameter is equal to or greater than the right, well, equal to will probably work, but if left is greater than right, well, we're done. We're done sorting that particular list. That is when you break out of this recursive algorithm. So you should do all this if the left parameter is less than the right parameter. And then when this is all finished, the function should return the sorted list. You actually return, yes, you're returning a parameter, but it will now be sorted as opposed to unsorted. That, everyone, is a quick synopsis of how a quicksort method works. If you have any questions, please send me an email at kmuldrow@lbcc.edu.